Technology is currently growing at an exponential rate, and architectural formations are becoming more complex every day in order to address society's needs. Typically, the use of lumber is reserved for simple residential structures. However, timber has the potential to accomplish the same complex form as most building materials. There is also potential to take this concept even further by using recycled wood. When used, the difference in each member of the material can begin to not only accomplish a predefined form, it can increase the complexity of the structure. With an increase in complexity, there is an inherent need for a defined process to develop the formation. The main idea is to organize recycled material, wood in particular, into a performative architectural element. By understanding the differentiation of material, the design of space begins to be informed by the material qualities. With this system, we can achieve mass customization rather than the individual customization of pieces. To better understand how to account for the variability of the material, a series of prototypes were performed. These range from exploring spatial conditions, attempting to create a form, and testing connections. Each prototype, whether a success or failure, should divulge new information about the potentials of the system. Once there is a better understanding of the parameters of the material, a process can be defined to implement and adapt design based on the spatial needs and material limitations. After developing the build system quite a bit, the manner in which I could use the process to inform the design began to emerge. This method can be used in several scenarios, such as a shelter condition, for instance, a temporary place for refuge in disaster relief, or for the homeless. Another potential is for interior performative conditions, or as a pavilion in public space. The adaptation of the design depends on the prospective users and how they choose to interact with the architecture. During the construction of some of the prototypes, certain issues with the strategy became clear. By doing a full-scale prototype, I directly addressed the problem of material density and time efficiency. Although it was not started with a clear solution, a defined rule set emerged, which helped mitigate both the use of time and material. The strategic placement of pieces and connections will begin to influence the design of future prototypes based on its limitations. Another problem that must also be integrated into the prototypes is structural support. With the improved process, structural integrity is uncertain, so I explored the limitations of several organizations. The key will be to understand the geometry of these columns and define how they can be intertwined into the current process while using the same tools.